Ali Oxenfree. That looks okay. Testing, testing. Can you hear me? Can you hear me? Something's a little off. Let me check something really quickly. Input. Output is there. Input needs to be this guy. Oh, okay. I think that's better. Testing, testing. Ali Oxenfree. Testing, testing. Still looks a little low. Is it? Hello, hello? I still think it's not right. Hang on. Hello, hello? Input. Okay. Is this not the more that I can do? All right, let's get started. Okay, I'm just taking attendance as I let you all in. Got one more. Okay. All right. So I can't think of any major announcements. We still are doing online asynchronous. So once you get into my Zoom, you've got an attendance credit for the day. And I'm just going through homework. So like with my classes earlier, some things that we've done, I usually do different things with all the classes to encourage you to like make use of my videos. So one, I'm not repeating myself all day. So I'll say it once, and because I'm live streaming, I rely on that, and I expect you to as well. So like with my 2 p.m. class, I went on and did section 1.5 transformations of functions, right? So that's just being a little bit ahead. But with the rest of my classes, like my 9 a.m. and my 3 p.m., we've been kind of working through the homework. So I think between the 9 a.m. and the 3 p.m., we did section 1.2. So with you all, I'm going to start on section 1.3. If you like have questions from 1.2, you just have to go back to like a previous session with somebody with one of the groups from today. If you have questions, feel free to type it in the chat. I'm going to go ahead and suppress my audio just so I can focus. But if you like need assistance or have questions about anything, either type it in the chat or raise your hand. And let me mention this other thing. So let's be ready for exam 1 this upcoming Wednesday, so a week from today. It should become available like at midnight between Tuesday night and Wednesday, and it'll be available until the following Monday at 9 a.m. All right, so from whenever it's released until Monday morning at 9 a.m., which is about 5 days, give or take, you can earn up to 100%. All right, and you get unlimited attempts. But after that Monday morning at 9 a.m., you can still keep working on it and improve your score, but it's a 10% late penalty. So the highest that you can get if you submit it late is a 90, which is still an A-, which I think is fair, right? But if you want like something higher than a 90, then you want to work on it to submit it before that Monday. That exam is only going to cover sections 1.1, 1.2, and 1.3. So that's what you're responsible for this first exam. So that's why we're going through the homework for like sections 1.1, 1.2, and 1.3. Let's see if there's anything else before I check the chat. Exam is next Wednesday. Again, for that exam, you're only responsible for sections 1.1, 1.2, and 1.3. I've loaded all of the homework. I've loaded all of the homework and all of the quizzes for the semester. I think for you all, you should have an extension on the homework, right? For like the first few homeworks, because we got started kind of late. I think I factored it in already for you all, right? But we still kind of got to keep up So we still need to be working on the first 3 sections and be ready for exam 1. But I'm okay. I'm open to, like, for those first 3 sections giving you all an extension. But I think I already did it. I think I've already done that for this group. Let me say this about the exam. Again, with all of my assignments, I generally do unlimited attempts at all assignments. As you make your way through the quizzes are going to be similar to the exam as far as formatting. The quizzes are really short, they're like 5 questions, but you'll notice that you don't get the learning aids. You don't get to, like, help me solve this, all this. You can't see your score until the end. So when you finish the assignment, if you don't like the score, you can take it again. Now, this is the thing I wanted to say about the exam. I don't mind doing unlimited attempts, right? But I basically did like a pool with the exam. So what that means is, like, every time you take the exam, it's going to change, right? It'll be the same content and the same sections and same type of questions, but it's going to change up each time you take it. So you can take it as many times as you like. You can get essentially whatever score you can get to any letter grade that you want. You just got to kind of keep going until you get there. Okay, and just want you to be aware that the bulk of your grade is going to come from the exams. Now, right now, we're preparing for exam 1. I know exam 2. I'm still more leaning towards an oral exam. I still hadn't worked out the details of how I want to do that, but for exam 2, I definitely want to do something like that. Let's look at the chat and see what's going on there. No, you don't have to have your cameras on. On your end, the main thing I need you all to be doing, completing those assignments in Pearson. I make, like, my sessions, the recorded sessions, available on my YouTube for your reference, right? So for this week, this is the end of week 3, so you should be wrapping up section 1.3. In the lectures, I've made at least through section 1.5 available, but for exam 1, you just need 1.1, 1.2, and 1.3. And the main thing are just completing the corresponding assignments on Pearson. You access Pearson through Blackboard, right? So you go to our Blackboard, folder number 4, follow the prompts for the assignments, right? That's where everything is. So the questions that you see me working on, you access them through Blackboard, and you do have to purchase full access to Pearson. It should. One of the students was telling me it was about $105, right? So I know it seems like a lot, but what if that was your favorite video game? What if that was your favorite shoe or sneaker? Or what if you decided to go to a restaurant? Then, that's all relative, right? If it's something that you want and you get direct, instant gratification, then it's different. So if we can do all these other things for what we want, let's do something to improve ourselves, to make ourselves better. And, not that the math is going to make you better. It's just, it's gonna position you so that you can, like, do more for yourself. You know what I mean? Let me see. So the lab, you gotta for the lab, you want to communicate with Dr. Lamar. So she runs the lab. We're actually just doing, this is actual lecture. Yeah, just talk to Dr. Lamar concerning the lab. Anything with the lab, you just talk to her. Whatever she says, that's what you do with the lab, right? Okay. My recommendation, okay, again, and so we are doing online asynchronous. As far as my class, you're not obligated to stay. My recommendation is just to hang out. And if what I'm talking about is too intense, just use this time to go ahead and be working on your homework. Even if you're not really listening, just try to, like, listen in a little bit. But just use this specific time to work on your homework. Because if you make it a habit of not doing your homework, at least now, or then what could happen, what happens with a lot of students is they kind of like procrastinate, and it piles up, and then when they sit down to do it, they don't have enough time to do it, right? So to be gentle on yourself, you want to give yourself as much time as possible to make your way through this material. It's I would say a lot of these concepts are simple, but they're just not easy, in the sense that it's information overload, right? And so the way you combat information overload is organization and giving yourself as much time as possible. Okay. So let me, again, I am monitoring the chat, so if you have questions, feel free to type them there or raise your hand, and I'll get to you shortly. But we're going to go ahead and hop on over to Pearson, and we're going to start working on section 1.3. So again, these sessions are live streamed on my YouTube. I have 2 playlists that I'm updating. There's one playlist where I'm doing an update for current like lectures for, like, each section, and then the other playlist is almost like a catalog. It's just a collection of all the things from the spring and all the things from this semester, right? But it's pertaining to the same material. So one is just for the lecture, the other are like homework sessions and things like that, right? Um, also make use of, so hopefully you should be able to see my screen. Make use of this Ask My Instructor. I've had some students, I don't know, I guess it's helping them, but when you click on this, it'll send me a screenshot of your question. I'll load it onto my tablet and I'll make a dedicated video response. I'll make it at my earliest convenience, right? And if I don't answer your questions by the next time we meet, just ask me the next time we meet. Um, I'm feeling like Monday might be a holiday. If it is a holiday, we probably won't meet. I think it might be Labor Day. I need to confirm and kind of ask around. I'll be in contact via email if that's the case, right? So with this section, let me see, the chat looks okay. So this is section 1.3 functions. It says determine whether the relation is a function and give the domain a range, right? So this is called the correspondence diagram, and this is basically like a set of ordered pairs. So your x comma y's, right? So I think when we first introduced this, we said that if we have repeating x's, then it's not functional. Just like in life, if you kind of like keep backtracking to all your x's, it's just going to cause trouble. Generally speaking, not across the board, but you know it could be dysfunctional, right? So same thing here, right? If we have repeating x's, then we say it's not a function. So if we were to list out these ordered pairs, we would have repeating y's, and that's okay, but we don't want to have repeating x's. So is this a function? We're going to say yes. We don't have repeating x's. The domain are a set of input values, so you just write each input once. So we have 18, 15, and 11. Okay. And the range of the set of outputs, again, we just write each output once, which is 6 and 18. All right. And again, you can unlimited attempt. So you get a question wrong. If you hit similar question, take it again. The system is set to take your highest score. Determine the domain and range of the relation, and then decide if it's a function. So the domain are basically the set of inputs. It's missing -1. We got -3, -2, 0. I need a number pad. 1, 2, 3. We hit enter. Set of inputs. And then the range is a set of outputs. We got 2, let me see, 2, -1, 0. We said 2 already. Let's do -2. Okay. No notifications. Is the given relation a function? Do we have any repeating x's? Notice there are no repeating x's, so we're going to say yes. Okay. Determine whether the following equation defines y as a function of x, right? If we were to solve for y, right, we would get y equals -x plus 3, -x plus 43. So that's going to be the equation of a line, right? And lines are going to pass the vertical line test. So I'm essentially getting a sense of the graph of this. And when you look at the graph, once you solve for y and plot that, you'll see that it passes the vertical line test. One software, like if you want to get some digital graphs going, is this site called, I usually use GeoGebra. It's like algebra. It's GeoGebra. It's like geo. It's like algebra and geography, so it's GeoGebra. It's kind of weird, but it's an online graphing software. It's free online graphing software. You can type. I think you can type in x plus y equals 43, or just solve for y. You can do y equals a -x plus 43, graph it, and it'll pump out the graph. Another one that students use is this one called Desmos. I could show it, but I'm just not going to show it right now because it's too much to like show the screens. I'm not showing my desktop, and it's just too much. Let me check the chat. Chat looks okay. So we got a yes on this one because when we look at the graph, it passes the vertical line test. Every x corresponds to 1y. Determine whether the equation defines y as a function of x, right? So notice we got y squared equals this thing on the right. If we solve for y, right, to get rid of that squared, we'd have to take the square root on both sides. And I think at one point we mentioned something to the effect of every time we introduce square root, we have to include plus or minus. So because of that plus or minus that would be in front of the square root, one x is going to correspond to two different y's. So then that would be a case of repeating x's or an example of something failing the vertical line test. So then that would be a no, right? You would have one x that corresponds to two different y's. Okay. So now this one, because the x square root is already there, we don't have to introduce a plus or minus. So this is like the top half of a sideways parabola, right? So if we have just the top half of a sideways parabola, is that going to be a function? If we look at that graph, it would pass the vertical line test. That would be a yes, right? I know we're just kind of breezing through these, but I mean, that's how simple they could be, right? Now, I don't know if, again, I want to be clear, there's a distinction between simplicity and something being easy, right? The concepts are simple, but I know if learning it is definitely can be information overload, so that makes it not easy. Man, water never tastes so good until you're like talking too much or running or like exercising or something like that. Let me see the time really quickly. I'm going to update my attendance. We're missing some people. I'm going to have to track these guys down. Yeah, he's usually here. I remember that name. I hope these guys are okay. But I'm gonna go ahead and suppress that for right now. Okay. I think this one is similar to one we did earlier, right? If we solve for y, right, subtract x squared on both sides. When we go to take that square root, when we introduce square root, we would have to do plus or minus. So the simple thing is because of that plus or minus, it's not going to be a function, right? You would have one x corresponding to two different y's. Okay. This one, okay, this one's interesting. If we solve for y here, right, we subtract the x to the fifth, we'll have 32 minus x to the fifth. Now, in the past, we were doing square root, right? This one, to get rid of that power of 9, we would do the ninth root. So you only have to introduce plus or minus whenever you're doing an even root, right? Because we're doing an odd root here, because of that 9, because it's odd, you don't have to introduce plus or minus. So because you don't have to introduce plus or minus, this is going to be a function, right? So if we ever had to do an even root, that's what causes it to not be a function. But the odd roots, you can do an odd root and still be functional. Okay, I hope that explanation made sense. So find these results for this function. Okay, I think I'm gonna take some notes on this one. This one I'm gonna write out. Okay, let's go paper. I like graph paper. Okay, so this is question number 8. I don't know why all of my stuff seems like it's so noisy. My chair makes a lot of noise, my table makes a lot of noise, but the floor is quiet. It's nice and good. Question number 8. This comes from section 1.3, question number 19. Ow. Did I cut myself? That's so weird. We're asked to find, we got g of 0. I'm taking some notes right now. G of -3. Okay. G of 5. And G of 4/3. Let me do and G of 4/3. All right. And the function is given on bottom. We have this 9 minus x squared inside the radical, and that's under x. And this is our g of x. Okay. So basically, we're evaluating these functions. Evaluating the function at different values. Let's hop over to the tablet. Everybody can see. That's fine. Okay. So let's start with g of 0. All right. I'm just going to copy all the stuff that I need. Basically everything except x. Copy. Actually. Oh, I didn't even see that x. I almost got that x. Yeah, I think this is everything. Let's copy, paste, delete that. Okay. So the first one is g of 0, and let's start by replacing each x with a blank set of parentheses. Okay. Let me do one other thing. Give me just a moment. This is what I want to copy this. Copy. Okay. So when x is 0, so we're going to replace each x with a 0. Doggone it. I just realized something that I'm missing. That's fine. And we're missing this squared right here. Just being a little bit OCD. Square root like that. Okay. Let me get a copy of this. This is better. Copy and put this in place. Okay. So now we're replacing each x with 0. So 0 there and a 0 there. Okay. All right. So then 0 squared is 0. 9 minus 0 is 9. Okay. So the square root of 9 is what? 3, right? So then this is going to be equal to 0 over 3. Now let me mention this. Let me share this information. Say we have 0 divided by some number, right? This is okay, all right? What is this equal to? 0 divided by some number. This is going to be equal to 0, right? This is okay. Versus, what if we have some number divided by 0? That's a KO. You want to knock that out, right? So some number divided by 0, that's going to be undefined, all right? So 0 divided by some number is okay. That's going to be equal to 0. But some number divided by 0, that's a KO. You want to knock that out. That's going to be undefined, right? So this example that we have, do we have an OK or do we have a KO? So we have an OK. So because this is OK, this is going to be equal to 0. Okay, I just wanted to mention that part in purple. Okay. So then the next one is g of negative 3. So then I'm just going to paste what I copied earlier. Awesome, it's still there. And now we want to do g of negative 3, negative 3, and negative 3. Okay. So I'm going to kind of start with the denominator and that radicand. Negative 3 times negative 3 is a positive 9. Uh-oh. So we got 9 minus 9, square root under negative 3. So then long story short, we're going to have negative 3 divided by 0. Is that okay or is that a KO? This is a KO, right? So this is an example of something that's undefined. Or does not exist, blah, 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 blah. No real answer, something like that. Okay. Let's do g of 5. That's the next one. Let's paste. We're going to do g of 5. Okay. So then if we start, I'm going to start with the denominator. 5 squared is 25, so we're going to have 9 minus 25 under 5. What is that? That's 15, 16. That's a square root of negative 16. So I'm going to say not a real answer. Because we can't take the square root of negative numbers, all right? Okay, let me check the chat really quickly. I know I'm going a little bit fast. I'm just kind of doing this rhythm because it's a recording. So we could always go back and change the rhythm, right? If it's a little intense now, just kind of listen, kind of maybe put it off to the side and work on your own assignments and just stay present. Because I might say or do something that you might want to hear, right? And if not, at least you're being productive. So that way, once class is over, you don't have to be thinking about this all weekend. You can enjoy your weekend. Let's do g of 4/3. G of 4/3. 4/3, 4/3, 4/3. Okay. So 4/3 squared is going to be what? 16 over 9. So we have 9 minus 16 over 9 under 4/3. Let's see. 9 over 1 is the same as, so we're going to have 81 over 9 minus 16 over 9. We want the square root of that result under 4/3. Let's see what else we got. Let's keep going. Let me see. If that were 20, that would be 65, right? So then we get 65 over 9 square root under 4/3. So that's going to be the square root of 65. That's not a 6. Square root of 65 over square root of 9 is what? 3 divided by 4/3. So if you flip and multiply, this 3 is going to cancel this one. They might want us to rationalize. Right now, I'm going to leave it as 4 over the square root of 65, right? Because 65 is not a perfect square. So I get something like this. Now we could rationalize and move that radical to the top, which is, I'm just going to kind of look at the instructions and see how they want us to submit it. Let's hop over to Pearson. Man, I don't know about you guys. I am good on talking for the rest of the day. Yes, there's only 10 minutes left on the clock. 10, 15 minutes. We're almost done. Man, that was a weak battle cry. We're almost done, all right? 15 minutes. I've been talking all day. I'm good and done with talking for a little while. Okay, let's submit these results that we got. Okay, so G of 0, we got 0. Let me hit enter. Okay. G of -3, we got does not exist. Okay. G of 5, we got not a real answer because we got the square root of a negative. It's not a real number. It's an imaginary number. So we're going to have that discussion a little bit later. Okay. Let me see the chat. Okay, we got it. Okay, I'll check that chat in just a moment. G of 4/3, we got, okay, let me see. Type in exact answer using radicals as needed. Okay. We're going to do 4 over the square root of 65, and then we'll go from there. 4 over square root of 65, enter. Awesome sauce. Oh, that was it. Okay, so let's check the chat. I know there's some activity there. How do we access Pearson? So we access Pearson through Blackboard. So you log into our Blackboard. It's going to be folder number 4, and you're going to see something that says all assignments. When you click on all assignments, just follow the prompts for Pearson, and it's going to prompt you to pay. Full access costs about $105. If you're not ready to pay right now, you can go ahead and get 14 days of temporary access. So just look for that towards the bottom of the screen. So that, because I want you guys to go ahead and get started on your assignments. Because again, we have exam 1 starting next Wednesday. You'll have 5 days where you can get full credit. After that Monday, the highest you can earn is a 90. All right. So, good question. Yummy, yummy water. Oh my God, gotta have good water. Like that's imperative. So when you go to our class in Blackboard, and there's only going to be one link, you open up that link. It's folder number 4 that says assignments. So you go there. That's where you can find it, and then you just follow the prompts from there. Okay. Find the domain. Okay, this is a good one, right? So with something like this, the domain of a rational function, something like this, is going to be all reals except any x that makes the denominator 0. Okay, again, this is a rational function because it's basically like one polynomial over another, so it's like a fraction. So again, the domain of a rational function in general is all reals except any x that makes the denominator 0. So what value of x makes the denominator 0 here? So if you set the denominator equal to 0 and solve, you get -1. So, any real number is going to work except -1. So we want something that captures everything except -1, right? Do you know the difference between B and D, right? For instance, B has parentheses and D has brackets. Brackets means we include those endpoints. Parentheses means we get really, 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 really close to that number, but we don't include that number, right? So since we want everything except -1, it should be B. B is how we would express everything except -1. Remember, parentheses means we get really, really like infinitesimally close. Okay, we got one of the stragglers. I think I'm gonna mark him as late. Sam, I was like, let me see. Yeah. Let me go here. This one. Cool. Let me let him in. All right. All right. So I was being a little lenient. I know I just had someone to join. We're about to wrap up class. I don't know. When you coming in at this time, it can be kind of a hit or miss. It's based on my mood. You're at my mercy. Like if you make it in, once you make it in past 15 minutes, you're at my mercy. So as long as I'm in a good mood, maybe you get some favor smiled on you. I went on. So whoever I just let in, I just marked you as late. Usually this late, I'll let you in, but I can keep it as absent. But I'm still being a little bit lax right now. Because the attendance has actually been pretty good overall, and I do appreciate you guys actually staying. But again, you're not obligated to stay, but I do appreciate you staying. So it's no worries, Another thing is I want you guys to be aware that don't stress too much about the attendance. Like it doesn't really affect your grade directly. It's just for record keeping. The only time that attendance really becomes an issue is like once we hit about 3 unexcused absences, definitely at 4. Then administrators come looking for you, and like you could potentially be withdrawn from the course. And then like the later, late in the semester is really hard to get added back if at all possible. But it's really just for record keeping. And as long as you're communicating with me, I just make a record of it, and it's okay. Like I don't want you guys stressing about that. I know I've had some students concerned about their grades, so it's like it doesn't affect your grade. It's okay. It's okay. It's totally okay. We're here. And that's another reason I do asynchronous. And that's why I be kind of lax about the attendance because, technology is technology. My stuff be going crazy sometimes too. I don't want to do a similar question. I would like to go on to the next question. Is that the last one? Let me look at these questions. Okay, no. We still got a good amount. On to the next one. The time, and I don't want to keep it. I want to keep it for about another 6, maybe 8. 7 minutes is the number I was looking for. Okay. Find the domain, right? So here, let me take some notes. But it's the same thing. We have a rational function. Again, in general, the domain of a rational function is going to be all reals except any x that makes the denominator 0. So let me take some notes here because I want to write some stuff. So this is question number 10. This comes from section 1.3, question 25. 1.3, question 25. I'm going to say find the domain. Okay. And on bottom we have this x squared minus 4. On top we have this x plus 7. On the left we have this g of x equals. Okay. Let's hop over to the tablet and see the notes that we're taking. Okay. Also, all the stuff that you see me writing for any of my classes, you can actually find digital. I loaded a PDF of my work on Blackboard. Also, I think I made like a Dropbox available on Blackboard. So when you see those folders, folder number 8 should say Dropbox. You should be able to load the last page of your syllabus there, right? So I just remembered to say something about that. Okay, so something like this again. In general, the domain is all reals except any x that makes the denominator 0. So we want to set the denominator to 0 and solve. So here we want to set the denominator equal to 0 and solve. So then we're going to have this x squared minus 4 equals 0. We can do x squared equals 4. Just added 4 on both sides. Like this. To get rid of that square, we take square root. We said when we introduce square root, what do we need to do? Because it's an even root, we need to do plus or minus, right? So on the left, they cancel. So on the left, we're left with x. Square root of 4 is 2, so the x equals plus or minus 2, right? So what we're saying is that all the x's will work except plus or minus 2. We have to throw out plus or minus 2 because they make zeros in the denominator. So if we want everything except plus or minus 2, so let me see. Like for instance, if we're on a number line, hang on. So if we're on a number line, say this is the positive x direction. Say here's our -2, here's our 2. We want to capture everything except these guys, right? So we want everything to the left. We want everything between these two. We want everything to the right, right? So then what we do, we use parentheses. Parentheses. Kind of like that, right? So to capture this in interval notation, the far left of this graph, the very, very left, is going to be negative infinity. Up to -2. Then we want everything between from -2 to 2. Then we want everything from 2 to the far right, which is infinity. The infinity symbol always gets parentheses. In this case, because we don't want -2 and we don't want 2, we use parentheses around those numbers. And we combine these intervals with this symbol called union. It's like a U. It's just a U like that, right? So this is going to capture, this is the domain. These are all the numbers that's going to work. Basically, this is saying everything except plus or minus 2. Okay. So we're going to hop back over to Pearson like this. So the domain in interval notation, okay. Double parentheses, the far left is negative infinity, comma, -2. Then I'm going to do cup or union. I want to go from -2 to 2. And then it's cup, which is union, 2 to infinity. 2 to infinity. Okay. Okay. Next question. Let me check the chat. So again, if you don't say anything, I'm just going to kind of power through. We got time for maybe one or maybe two more. Find the domain, all right? So we have two restrictions we need to impose. The first thing is that we're dealing with a rational function, so we can't divide by 0. Secondly, we can't take the square root of a negative. So not only does that radicand need to be greater than or equal to 0, it has to be strictly greater than 0, right? So it can't be equal to 0. So then if we say x plus 3 is strictly greater than 0, if we solve, we're going to get x is strictly greater than -3. So we're going from -3 to infinity. Infinity always gets parentheses, and again, we can't be equal to -3 in this case, so we use the parentheses there as well. If I need to write that out, just let me know and I will. I kind of spoke my way through it. But if I need to write that out, just let me know. Okay. Find the domain, right? Okay, this one I'm going to write out. So this is question number 12. Let me see the time. This will be the last one for the day. There's a request in the chat. Hang on. Do collinear. Okay. If you had one ready to go, I actually did a collinear with my previous class. If you watched the recording for the 3 o'clock session today, it's one there. There's one in there. I know you'd have to kind of fish through, but we did one with that one. Let me finish this one up. If you could find one, we might be able to do it before later if we want to go. Let me go ahead and do this one. So this is question number 12. This comes from section 1.3, question 29. I'm going to say find the domain. Find the domain. Okay. On bottom, we have x squared minus 2x minus 3. On top, we have x plus 4. And on the left, we have f of x equals. Okay. So we want to find the domain. I'm going to hop to the tablet. Okay. So in other words, again, with a rational function, the domain in general is going to be all x, all reals except any x that makes the denominator 0. Right? So we got to basically set the denominator equal to 0 and solve. So that's going to be x squared minus 2x minus 3. We want to set that equal to 0. This is a trinomial, so let's see, can we factor this into something of this form? X and x. This second sign tells us that the two signs are different. So one is positive. I see the chat. I'll be there in just a moment. The two signs are opposite. So one has to be positive, one has to be negative. This first sign tells us that the larger number is negative. We're looking for two numbers that multiply to give us negative 3 and add to give us negative 2. I think that's negative 3 and 1. Negative 3 and a positive 1. Negative 3 times 1 is indeed negative 3. Negative 3 plus 1 is indeed negative 2. Okay. So then ultimately we get what? X equals negative 1 and 3. So long story short, we have to throw out those two numbers. So if we're on a number line, say, so if we're on a number line, here is our negative 1, here is our 3, and we want to capture everything except these two numbers, right? So we want everything to the left, we want everything to the right, and we want everything in between, but we don't want those two numbers. So that's why we use parentheses. Parentheses. So then to capture this in interval notation, the far left is negative infinity. Up until, what is that, negative 1. Then we want everything from negative 1 to 3. Then we want everything from 3 to infinity. Infinity always gets a parentheses. Because we don't want negative 1 and 3, these symbols, these numbers all get parentheses, and we combine them with this union. Okay. Let me see if this is on Pearson. I'll answer the question in the chat, and then I think that'll be it for this week. Okay, you guys have work. You have your work cut out for you. Let's hop over. Pearson is here. Let's see. It's not B. Only one that matches is A. All right, I'm gonna go with that. Okay, let me check the chat. Okay, collinear. Okay, let me go ahead and do this one. I'm not sure where it comes from. I'm just gonna put a star and it's gonna say requested, request. Let's hop back over to the tablet. Which is this. And I need to see the chat. Like this, it's one of these. Okay. So we have a request. We're asked if these are collinear, question mark. And we have this point 0, negative 8. Yeah, we definitely did these. Negative 3, negative 16. And 2, negative 2, right? So I may or may not do it the way the book does it. I'm just going to do it my way, right? So for these guys, I'm going to find the equation of a line through 2 points and then confirm that all three of these points are on the same line. So I'm going to use the first point and the last point. Let's find the slope. First, let's start by finding the slope. So the slope formula, y2 minus y1 over x2 minus x1. Again, this is the slope. And I'm going to do like this, x1, y1, and I'm going to say x2, y2, right? The first and third point just look the most simple to use in my opinion, just at first glance. So y2 is going to be negative 2 minus y1, which is 0, over, that's not right, back up, minus y1, which is negative 8, over 2 minus 0, right? So double negative becomes positive, so we have negative 2 plus 8 over 2. 8 minus 2 is what, 6? So this is going to be 6 divided by 2, which is 3. So that's the slope there. So now, for our line, we have that the slope is 3. We're actually given the y-intercept because that first point is actually the y-intercept. X is 0, so our b is actually negative 8. So we didn't have to do a calculation for it. We were fortunate they gave us the y-intercept. So a candidate for the line through the points would be, again, I'm using slope-intercept, which is y equals mx plus b. So the m is 3, our b is negative 8. So we want to test this. We want to test all 3 points in this line, in this equation. So notice when x is 0, notice that y is negative 8. So the first one checks out. When x is negative 3, 3 times negative 3 is negative 9, 17, right? Negative, that looks like a no. Yeah, 16, 17, right? So this one is not on there. So are these 3 points collinear? We would say no. The third point should be on the line because we use that point to generate the line. When x is 2, 3 times 2 is 6. 6 minus 8 is indeed negative 2. So are the 3 points collinear? No. Okay. I definitely did this one a couple of times, but it's okay. I don't expect you to go through all my videos, but you know. But it is a good idea to be subscribed to my channel with the notifications on, because sometimes students like use the Ask My Professor, and I'll just at random hours do a dedicated video. And this is, I know I've done this one a couple of times, so you know, so I'm not repeating myself so much. If you see that, you'll be like, oh, wait a minute, I remember he did a video on this. Let me go watch that video, right? But it's okay. Okay, I think that's time. I think we went a little over with that last one. If there aren't any burning question, guys, just kind of keep working. Let's be ready for exam 1 to be available next Wednesday. You definitely want to seek out the tutors, link up with your classmates, and I'm here for support. All right, guys, thank you. Enjoy your weekend. Take care. From one beautiful mind to another, take care. Peace.